Good afternoon, everybody. Thanks for joining us on Build 2023. I hope you're all having fun learning new stuff. So this is a session about Azure Cosmos DB for MongoDB, and we're doing a Q&A on choosing the right architecture with Cosmos DB for MongoDB. So I think we should start probably by introducing ourselves. Gahl, if you forward the slides. Quickly about myself, my name is Thomas Kovarik. I'm a cloud solution architect with Microsoft, part of our global customer success team, and I work with customers across the Americas on implementing Cosmos DB. Pass it over to Gahl, who is here in the room with me today.
Hey everyone, I'm Gahl Levy. I'm a PM here on the Cosmos DB team. You can ask me about Cosmos DB for MongoDB, or even more fun, DJing and choosing the right equipment for your AV setup. So I'm all about that.
And we are also joined by Jay Gordon. Jay, you want to go ahead and introduce yourself?
Sure. Hey, everybody. I am coming to you from the lovely borough of Brooklyn here in New York City.
Can't hear the audio.
Hey,
there we go. Yep.
Can you hear me now? Great.
Yes.
Hey, everybody.
Yes.
My name's Jay Gordon. You can find me here in the lovely borough of Brooklyn in New York City. I am a Cosmos DB program manager. If you would like, I can try to get you as much information about Cosmos DB. I formerly am of MongoDB and came over here to help you learn about MongoDB for Azure Cosmos DB. So you want to know something about music, just reach out to me and I probably can answer. Anyway.
All right, thanks very much, Jay. So yeah, we definitely have the expertise in the room, so please feel free to ask us questions. But we know how these sessions are, so we thought we would do like a quick show of hands just to get the action going in the room. Just kind of curious, how many of you here are using Azure Cosmos DB, any of the APIs today?
And if you're online, please raise your hand in the Teams meeting. We should be able to see it on our screens come up. Yeah, I see a few already coming up.
So it's about half of the people here in the room, and we got a bunch online. That's cool. So how many of you are using MongoDB in anywhere, on-prem, other clouds? Okay, that's roughly about half in the room as well.
A lot online, yeah.
Okay, quite a few online. Okay, that's very cool. And how many of you have experience with MongoDB on Azure Cosmos DB?
Yourself, okay.
That's fewer people.
A few online, yeah.
And a bunch online. All right. Yeah, it gives us a good feel for the audience. So thanks for that. Yeah, this is an open Q&A, so you guys are very welcome to ask us any questions you have about a service. We do have a couple of questions, so we pre-prepared. We thought could be relevant for most of you, but we will only use them if there are no questions otherwise. So either please use the chat or just raise your hand and we'll pass you the mic.
Right, anyone here in the room? We're also looking at the Teams chat as well, but I'll start here. Anyone have a question?
Hey, Gahl, we have a question.
Anyone who has a question in the room will get a free coaster and a sticker, and then a free drink I'll buy you a drink and the free drinks downstairs with that coaster.
Okay, Gahl, we have a question online.
A question online. Great. Okay.
Address this one over here.
Why? Okay. So the question is around using Cosmos DB instead of MongoDB Atlas. Like, what's the point? And that's a very fair question. So we have some slides. Like, I can actually show a slide around this. Some of the differences. So one thing people might not realize is that Azure Cosmos DB for MongoDB does not run any MongoDB code whatsoever, 0%. It's all built on Azure Cosmos DB. The API is just a translation layer, taking your MongoDB queries and translating them to Cosmos DB. So the real question there is, why should I use Cosmos DB in general? Some of the reasons, the most basic one, it's a native Azure service, so you get first-party integrations, which is always nice. You don't have to build them, you don't have to support them yourself. But secondly, this kind of goes into the two architectures as well. We can talk first about the request unit architecture. There's benefits to using Azure Cosmos DB. It's a multi-tenant service that's cloud native, that's actually using a giant pool of resources that get assigned to you instantaneously. So it's not a service with VMs where you provision VMs and wait for them to spin up, unless you're using the vCore architecture, of course. So what that means is if your users need more power, more database power, it's instantaneous because it's just getting resources from the cloud for you, which we can do because we have a giant pool of resources we assign to people. That's a big benefit. Some other benefits are integrations such as with Synapse Link. You can push all your data to Synapse automatically, no ETL, it's just a checkbox. Integrations with many other Azure services. Those are some, but I don't want to spend the whole time talking about that. Let's see if there's a follow-up to that. Native to Azure, not using integration. Yes, okay. One last thing I should also point is the SLA as well, because that's important to mission critical applications. So when you're using the, it keeps moving, I don't know why. When you're using the request unit architecture, you get 5 nines availability, meaning that because we're able to spread multiple writable primaries across the cloud, we can get you a higher SLA, and that's because it's just built on Cosmos DB. It's not MongoDB at all. So it's a different database, but there's benefits, pros and cons to using each. Any other questions I can start with?
Yeah, we get.
Yeah. Get the mic so they can hear too.
The document size is increased or still the document size is 16 MB, right? I think.
Yeah, it's 16 MB in both architectures, in request units and vCore. There's no difference there.
But MongoDB supports more than that.
It's 16 megabyte as well.
Is it?
Yeah.
Okay.
If I'm wrong, please correct me. But yeah, as far as
more, I think.
No, as far as this morning, it was 6.
No, last year we
No, so I think that might be some confusion around that. So if we talk about the request unit architecture, for many, many years, the maximum it could support was 2 megabytes. And as of last Ignite, so October, we raised that limit from 2 megabytes to 16 megabytes, but only for the Mongo API. So other APIs don't have this 16 megabyte. Only the Mongo API goes up to 16 because if people are using their Mongo applications, they want it to work the same. So we didn't want to limit them there. So that might be the reason why you see some differences.
And perhaps just to add to that, like just because we raised the limit to 16 megabytes, the thinking there was to allow, like, say, easier migrations, or if you're coming from elsewhere, you already have an existing Mongo application where you have some large documents, then with the higher limit, you can more easily port them to Azure Cosmos DB than with the existing, the previous 2 megabyte limit. But that said, if you're building a new application, we actually do not recommend that you create documents that would be, I don't know, as a rule of thumb, more than a couple hundred kilobytes really at the upper end. So, just because the limit is so high doesn't mean you should use it. And if you do, then the queries and the operations you perform with such large documents will be very expensive in terms of those RUs. So.
Yeah, and this applies to all databases as well, including MongoDB. It's an anti-pattern to have large documents, and I want to just make it very clear. I do not suggest you build applications with large documents, but if you must and it's time sensitive or you really have to, it'll work. Just don't make it a common practice. Yeah. Container. Yeah, it's like the question was around joins. So lookup operations do that. It's just a different syntax. And yeah.
Select one container, one option.
Yeah, exactly. Yeah, same. It's called something different in Mongo query language. Yeah.
We have another question over there in the room.
Sure.
Hi. So we've got a mixed environment with several types of databases, Mongo, Cosmos, a little bit of SQL Server. We'd like to migrate more of our legacy Mongo tables over to, or collections over to Cosmos. Is there a guideline for when it's best to take the pain and kind of switch over to the SQL interface versus sticking with the Mongo interface that we currently have? I mean, outside
Yeah.
16 megabyte limit that you just talked about. Yeah.
Do you already have large documents that are over 2 megabyte?
We'd like to get rid of them, so that would be part of the migration.
Yeah. So it depends on what's your openness to making application changes, because you're using Cosmos DB SDKs in the SQL API. It's a different coding interface, basically. So
sure, but I guess is the benefit of switching to SQL that much better than sticking with the Mongo, performance-wise or otherwise?
You want to think? Yeah.
Sorry, I don't have a microphone.
Oh.
On the performance side of things, you might actually get a small benefit if you adopt the NoSQL API, just due to the fact that it's proprietary. It's not open source based like the Mongo one. So with Mongo, you would connect using the open source connectors. So these are open source. These are not proprietary. Versus if you use the NoSQL API, we are both in control of the client SDK as well as the server side of things. So we can optimize things, the communication between the two sides a little better. And you can also leverage a direct connectivity mode. So there is one less network hop. So if you're really latency sensitive and you're building some large scale solution that requires very low latency, maybe look more into the NoSQL API. But otherwise, there's quite a good, close parity between the two. So
I support both. So I'm slightly biased towards Mongo, but no.
All right. Thanks for the question.
I guess one small follow-up.
Yeah, go ahead.
Right forum for it, but, is there any plan to offer a managed Mongo service on Azure?
Oh, like a managed like a managed MongoDB service.
Right outside of Cosmos. I guess that's probably not the.
Yeah, I mean, there's Atlas. That's one thing. It's not an Azure managed service. I would look more into like the licensing terms for MongoDB. I think as of 2019, 2018, they implemented a licensing restriction that prevents any company from running that product as a service. So it's not even legal to do so.
That's good. It's good to know the reason why.
Yeah.
Thank you.
Yeah.
Let me see if we have any question online.
Yeah.
There was a question online, essentially whether Cosmos DB is a good fit for only small projects or also projects with high demand.
It's fine translating what people are saying online. So I think it's like around size of projects, right?
Yes.
Like, should we talk about serverless and the ways that goes into it?
I think that's great. Yeah. So I think let me start this one.
Yeah.
So I think like there's a common misconception I see when I work with customers, in that they think like Cosmos DB is like, I'd say like the Ferrari. Only if you're building like the topmost critical application, tier 0 application, you're a retailer, you're building your product catalog or something like that, then you would put it on Cosmos DB. Well, maybe it used to be true in the past, but now we're really trying to fit both sides of the spectrum in the sense of like literally the smallest of applications as well as the most demanding of workloads. So we've always been on the right hand side for the demanding applications. Now we are doing a lot of investments around elasticity of the service to make it work for the middle side of the spectrum. And on the left hand side, so the small applications, we've I think it was around maybe like a year to 2 years ago, we introduced a serverless mode, which is a brand new like deployment form of Cosmos DB. If you're familiar with other serverless options in Azure, like functions or something like that, it's really a pay-per-use type of model. So if you're not running any queries, you're not paying anything for the compute. You're only paying for the storage. That's I guess to be expected. So it's really actually really good for like your small little personal application. If you were to build maybe a blog or something like that, you don't want to grab other database from Azure, which has some small entry points, say $10-20 a month. If you grab SQL or something like that, you probably really want to put the way down to zero. If you are not making any requests, or if you're making a few requests, then it's just a couple of cents per month for that. So Gahl, you want to add anything to this?
I think this is actually a good segue into something I want to talk about, which is the two architectures, including the new the vCore architecture we recently introduced. So the serverless part, it's called a capacity model. I think it's one way of running the request unit architecture, and that applies across all APIs. So you have serverless, you have autoscale, and you have provision throughputs. vCore is similar to what you might be used to if you're running a database locally on-prem or in IaaS. you're paying for instances and for disks. So we recently introduced this vCore option because it just maps one-to-one more from what people are used to and allows people to leverage that for new apps or for migrations in a much easier way. So now you have the choice of which one you want to use. Serverless is an option that's only available right now in request units. So that's one thing to consider. Let me actually touch on one thing around there was a question around MongoDB features, around features from different server versions. So right now in vCore, we support 5.0, and in request unit, I think it goes up to 4.2. There's definitely plans to do more in the future, since these are both options we want to give developers to choose. So feel free to give us feedback in terms of that as well, in terms of features that are important to you. Let me see if I hit all of the questions here. I'm going through like 5 of them. Yes, okay. Would this be a good time for me to talk about the differences between the architectures? Does anyone want to know about the differences between the architectures? Does that interest anyone here?
All right, maybe let's just do one more quick show of hands. How many of you have tried to preview Mongo vCore we introduced about a couple of weeks ago? Have any one of you tried it so far?
Everyone in the room. Wow. Okay.
All right.
Just for the people online, they can't see, so they'll So,
no,
I can take this. So on the simplest terms, they're both Mongo endpoints. So you can use native Mongo tools like MongoDB, Mongo Export to get data between that. If you're talking about large scale, like many terabytes migration, like Databricks with Spark, that kind of thing would be a much better solution. And we can always help out with that. We have tools to leverage that. So feel free to reach out if that's kind of your scale. But in the end, on the simplest terms, these are just Mongo wire protocol endpoints. So they talk to all Mongo tools.
I think just two points to add here. Like going forward, like in the future, we are evaluating the option of kind of introducing that one-click option you asked about, but that's we are evaluating that right now. So if it comes, then it's going to take a while. I think the more important question here is why would you want to consider or what would be a reason to consider moving from the RU, the existing one, or the established one, to the vCore one? And there may be a couple of options or a couple of scenarios when that would make sense. For example, if you're running heavy analytical queries on your existing RU model, these are not very well suited for the RU model, and you might be seeing high RU charges, and those obviously translate into a high cost. So that could be one example where you would you might consider moving over to the vCore model, which is, as Gahl mentioned, kind of a VM-based architecture. So it's better suited to handle the spikes in your workload. I'm sorry.
I can say that. So it really depends on the workload, and that's why we're kind of introducing this, because we want to bring flexibility. So you can choose which workload you want to apply to each architecture based on that. So for example, if you have long-running aggregation pipelines and that's all you're doing, you might want to go with vCore because it's just more well-suited. It's not a multi-tenant service. You have access to the whole machine yourself. But if you have really spiky applications where you want to be able to run very, very low, and then at 9 a.m. or 10 a.m. spike up 10x, only RU can offer you that, because it's just the architecture itself lends itself better to that. Some other things to consider is
Gahl, I would also add, like, there's the migration scenario. So if you are let's say if you're on premises with an existing Mongo installation, it might just be easier to move to the vCore model, because on-prem you will know, okay, I'm using 32 cores and 64 gigs of RAM, and I have this big of a disk, so you can grab the closest matching SKU for Mongo vCore, which has the sizing in terms of vCore's RAM of memory and disk IOPS, and you can just map it one-to-one, and the migration will be a lot easier than maybe trying to fit into the RU model, where you have to consider, okay, how many reads you're making per second, what's the size of your documents, how many writes you're making, the cost of your queries, and you have to kind of evaluate that and express it in the RU terms. You have to measure all this to arrive at a reasonable estimate. So it may simplify some of these scenarios as well.
But it just depends. That's the answer. And I know it's like a very MBA kind of like, it depends on everything answer, but that's the overall answer there. But just like you touched about, on pricing, with vCore, you just kind of pay a flat fee per hour for machines, just as if you were like renting machines in the cloud. With request units, you pay on your actual usage, as well as your consumed storage, your storage usage. So different models for different workloads. We should put a mic so that people can hear them online too.
So I'm planning to use the only microservices for the container. The microservices means it got only thin layer, right? So if you want to use that kind of microservices use cases, so which one you recommend, vCore or RU?
So if I hear right, the question is, you have microservices with two. Okay. Use cases microservice. Yep. Are you running in MongoDB right now?
No.
You're running in Cosmos DB right now. It's so, it's a fair question, but it's tough to say right now. Like, choose one without knowing like what kind of queries are you running. That's really the main question, because it all goes from that in the end. Are you running queries across? Are you fetching tons of document at once, or?
Yeah, I think there's one other aspect that we should probably mention that's support around the multi-region rights. So if you're building,
did he mention multi-region rights? I don't know if I want to go into
yeah. So I mean that can be like a point for consideration. I mean both of these systems support it, but one supports it in reads and writes in primary and reads only in secondary. That's the vCore model. The existing RU model can support writes in any region. So it depends on, again, the microservices. And if you have a multi-region setup and you're performing writes across multiple regions, then you have to stick with the RU one.
Yeah, I think it's better if we just take this offline and we talk afterwards. That way I can get into the detail I want in terms of the queries, because I don't want to. Yeah, that would be perfect. Yeah,
let's
talk
take
about
it
that right
offline.
afterwards.
Let's take it after the session. Thank you.
Okay.
Let's see. So there's a question in the audience asking, for developers who have trouble partitioning or sharding their data, is vCore recommended?
That's a good question. Yeah.
Let me get started on that. So yes, I would say 100% recommended in that case, because vCore, you might know that on the RU model, you kind of need to partition very early on. You actually have to specify a partitioning key. Otherwise, you can only store 20 gigabytes of data. With the vCore model that we have recently introduced, if you do not partition, we can now support up to like several hundred gigabytes of data, maybe maybe even closer to a terabyte of data.
Terabytes of data, and up, and
yes.
it's only going to go up.
Yeah, so we're actually improving that. So given it's kind of a VM-based architecture, we can put you on a really big SKU and allow you to store multiple hundreds of gigabytes or even terabytes of data before you need that second VM, and therefore the need to shard your data. So definitely, if you're struggling in that, look into the vCore model.
Yeah, and just to advocate for the RU model a bit, there are lots of benefits of having those small partitions, and if you have the cycles to do the data modeling up front, it does pay a ton of dividends later on. So it's something to consider. But with the vCore model, it's like the way you scale is you can do a lot more vertical scaling than before, than with the RU model. So you can scale vertically and horizontally a lot.
I'll pass you the mic.
Why would you not want to partition or not want to shard your data?
Okay. So just to repeat that question for folks online, the question was, why would you not want to partition or shard your data? Gahl, you have any thoughts on that?
Yeah, it's just because it's easier to get started, and there's no, some people just want to run as quickly as possible, and it's easier to vertically scale because it's all within one machine, makes things simpler. So it's just simpler.
Yeah. And I think the other reason is probably you need to have some understanding of your data and your query patterns, which you may not have, or you may not have good enough data sample if you're just in a lower tier environment and playing with a couple of gigs of data. So then
as you get more users, you'll better understand that, and then you can decide if you want to partition or not.
Mm-hmm. Right. I wanted to address one question we got online. It says, we are currently running in MongoDB Atlas, but we're thinking about migrating to Cosmos DB with MongoDB API. Some users aren't comfortable with MQL. Would they be able to query using SQL? So the answer to that is, let me say no. I'll get to that. So they have to, no matter where you run your Mongo, you always have to query with MQL. That's given. But if you use the RU-based version of Mongo, Gahl already mentioned that we offer plenty of native integrations with other Azure services. One of them includes our support for Synapse Link. So what you can do is you can hook up your Synapse Analytics environment into your Cosmos DB for MongoDB API, and we can automatically behind the scenes move the data from your MongoDB on Cosmos DB into the Synapse environment, and there you have a support for TSQL. You can do your joins. You can run large aggregate queries. You can run scan queries. You can put a heavy ETL job onto that system and completely isolate your MongoDB instance. So it's I would say it's kind of a yes and no.
Yeah.
I hope that answers.
I was online, right? Yeah. Okay. Let me expand on that. Okay.
Okay, so there's another question in the same spirit, asking for plans to support Synapse Link for the vCore model. Gahl, I'll have to defer to you on that one.
I mean, short answer is we are making integrations and we base them on user demand. So definitely, based on the demand that we receive. Let me. Someone say, okay, sorry, I thought I heard a question. Is there a question?
Is there a question? No.
Oh, okay. I saw a question come up online on vector indexing, so I just want to touch on that. Who here, with a show of hands, is aware of the vector indexing feature or what vector indexing is? Please raise your hand if you are. Someone?
You have all
Online.
attended this morning's keynote sessions, right? You heard a lot about copilots and
OpenAI over and over. So we brought that into this, this presentation as well, just to tie that all together because we're all Microsoft. So let me touch on that just briefly, just put a little sales pitch on this. But
go for it.
We introduced this feature. What it does is allows you to basically store your vector embeddings, which are representations of some, some object. So for example, your favorite song, or your songs or your products, and you can store that directly in the database now. And what that allows you to do is query for similar items in your database, all within one solution. You don't have to have a separate vector database to do so now, which means you can find similar items. So for example, similar songs to the song you're searching for, or similar products to the product you're searching for, or anything really, all in one solution. And that was introduced today, so just wanted to touch on that briefly. If there's any questions on that, let me know.
All right. I don't see any questions in the room, but we have another one online asking regarding native integrations. So that's referring to the RU-based one. What approaches are common for groups using Power BI wanting to interact with Cosmos DB base data? And the user adds Power BI SQL centricity versus NoSQL impedance. So I think we have kind of covered that in the previous answers. Really, our approach here is to position Azure Synapse Analytics and the Synapse Link integration, which is both non-impactful, so it doesn't consume any of your RUs. It doesn't add any load on your NoSQL data stores. That's very important. You probably have some critical applications that are running off of that Cosmos DB for MongoDB account, so you wouldn't want to put any extra load there. In addition to that, the other approach, besides using that, you would have to orchestrate your own ETL job and periodically copy data out of that account into some data warehousing system, into a data lake, so you could do further analytics. or maybe build those Power BI dashboards. If you were to do that yourself, then there will be some introduced latency because probably those ETL jobs would run like once per hour, once per 2 hours, maybe once per day or something, versus the Synapse link runs 24/7. It has latency of about 30 seconds to 2 minutes, so it's very close to real time. So yeah, we try to position that a lot, and it's very simple to get set up. I mean, literally as easy as ticking a checkbox.
All right, canned questions it is.
Yeah, I think
okay.
there was.
I'm so excited about that one.
Sorry. Yeah, there's another one. I'm seeing. Yeah, that kind of goes back to the discussion around MongoDB Atlas versus Azure Cosmos DB for MongoDB. It's a question about egress. So yes, that's also true if you're if you're building
between regions, yeah.
If you're building a solution that spans multiple regions, then there's going to be egress charges between those two regions, versus if you use the native service, meaning Cosmos DB, then those charges are covered. So that might be another kind of a point to consider when choosing.
Between the regions, there's still charges across regions.
Oh yeah, but they're bundled in the price for the RU model.
I don't believe so, but
I think for the RU model they are. Maybe for
maybe I'm wrong, but as far as I know, between regions, when there's those infrastructure costs do go towards the user in the end. Because if you're moving data between two regions, we get charged for it, so users get charged for it. Good time for the canned questions. Sweet. Okay. So. Let me see, what didn't I cover here? So what is the high availability option in the vCore architecture? So the important thing when you're doing vCore specifically is that you want to, let me see what's the best way to show this. I can show this in this demo thing. It should actually be here. Okay. So when you're creating a vCore cluster, there's an option for HA. If you're running production environment, if no downtime is important to you, select that option. The important part is select HA if you're running in production or if you're running something mission critical, because you want to have replicas backing your instances. So keep that in mind. But as always, when you select for more instances with vCore, you're just paying for instances and disk. So you just get charged for that immediately, so you get charged for that extra replica for HA. So just something to keep in mind. We want to stress it's really important to run with HA in production workloads. It'll cost more. So, get more questions. Let's see. I'll use it. Vector search to be first comments. I'm not sure about that one. I'll probably table that for afterwards. I have to double check on that one. Okay. There was a question around cognitive search, and I'm not sure about that one since it's not my product. I'll have to check on that. Any more questions in the room? Can help answer.
Go ahead. Yeah. I'll pass you the mic.
Thank you. Is there a recommended consistency level for multi-region writes?
Consistency level for multi-region writes. The short answer is a session, I believe, right? That's the.
I would say.
You might know this better than yeah.
Answer if it depends. So you'd have to tell us a little bit more about the application.
Okay.
We can talk afterwards
later.
if you want. The default is session, and that's the one you generally want to use. The thing is, if you use strong, I believe when you use strong, you're waiting for an ACK across all regions, right? So it's going to take a long time for the latency.
So I think like that's a common thing for customers. Non-relational database. It's got the first ever non-relational database, and they go for this, and they kind of they have this paradigm of using strong or as it's called in the SQL world, like linearizability and serialization. So they kind of try to apply the same or choose the closest consistency level to that in Cosmos DB, and that's obviously strong. So and that then limits them in what they can do with the system. And as Gahl mentioned, if you're using multi-region, then you have to get the ACK from every region, from every quorum in every region. It introduces quite a lot of additional latency for your workload. So I think it's always good to evaluate and understand what are the trade-offs before you settle on one or the other.
Thank you.
Gahl, you take the next one.
Sure. So how long ARIA supports high-level options compared to the regular Mongo? Sure. Okay. So we got a question around how the RU architecture supports HA, or like how HA works across many regions compared to MongoDB running in IaaS or something like that. The thing to remember with RU is it's in the end it's just a giant pool of resources located in each Azure region that we assign to your account. Meaning, for example, if you have multi-region write enabled, for the same piece of data, for the same document, you can write to that document across any regions. It doesn't have to be limited to one region for write. It can be written to any region at the same time, and the conflicts are addressed. That's very different to how it works in native MongoDB, for example. And then you want to touch on that as well?
Yeah, I'll let you speak to the vCore, but one thing to mention around HA is in the RU model, you by default get 4 replicas of your data. So anytime you write a piece of data, it gets replicated 4 times and stored 4 times across different nodes that are hosting the Cosmos DB backend. So it has pretty high availability right there out of the box, and then you can further increase that availability by adding those additional regions. So if you add a second region, you essentially are getting 8 copies of your data. A much higher, well, I guess durability, but also more importantly, much higher uptime, and you're also getting better SLAs on the system.
Yeah, and another thing to note is when you, even with one region, when you write to it, all writes are durable. So you don't have to worry about losing data when you write to a region, because you won't get an ACK back until it's durably written. If that makes sense. There's no configuration there that can be done. So.
That's supported on open source Mongo, right?
Yeah, it's a configuration. Like I'm comparing that it's not even possible to make that like a write conservative one.
I think that's actually a really good call out here, because if you were, let's say, if you were to install your open source Mongo or something, you can, as Gahl mentioned, you can use the write concerns and say, I want to run write to 1 out of my 4 replicas and acknowledge that as a successful write. We don't allow that in Cosmos DB for MongoDB. So by default, without any possibility to change it, we force you to write into 3 replicas, and then only then we acknowledge those writes as successful. So, but we kind of by default provide much higher availability right there out of the box.
Yeah.
Right, and we have about 5 minutes left in our session. So welcome 1 or 2 more questions, and
otherwise we can also chat one-on-one afterwards about your use case too. Any more questions online? There's someone we want to chat with online afterwards. Okay. Any more questions here?
No, looks like we don't have more questions online either.
Cool.
So.
All right. Well, thank you so much, everyone, for joining today. We really appreciate it. Please feel free to come up here, talk to us one-on-one. We can talk about your queries and any questions you have, and all that.
Yeah, thanks very much for attending, and enjoy the rest of the build.
Yeah.
Thank you.
Bye-bye.